The real number system consists of two sets of numbers. These are the rational numbers, which can be seen here, and the irrational numbers. Now, the rational numbers can be broken down further and further into integers, whole, and natural numbers. I find it really helpful to think about when we're doing this, the kind of history of how man has discovered numbers. If you were to go back to when you were little and you were to think, how did you start learning numbers? How did you learn to count? And you learn to count at the number one. And then you go up to two, to three, to four, to five, and so on and so on. So we refer to our natural set of numbers as our counting numbers. It's where we started to learn our number system. And then we evolved from there. I mean, we started with the natural numbers, and then we realized, wait a minute, we don't have a number for zero. And zero is a very, very important number, big number historically for mathematics. And so we had to create a whole new subset in the rational numbers to represent the whole numbers. So the whole numbers start at zero and then include our natural numbers of 1, 2, 3, counting upwards. And after we learn about zero and we have our natural numbers, we have our whole numbers, we need to dive even deeper into numbers. We start to evolve even more where now we have to count for negative numbers, the opposites of what we had as of natural numbers. We realize there can be such things as loss of value. So our integers subset contains all the negatives of the naturals and zero. And then if you go even further from there, we have to have these numbers all in between 1 and 2 and 3 and all these decimals that exist. And so that's where our rational numbers come in. The rational numbers are terminated repeating decimals. They are numbers that can be written as a fraction, hence the word rational, first 5 letters being ratio. So our rational numbers contain everything. Our sets evolved. And so rational numbers contain all the sets below. If we can even take a look, we see number one started our natural numbers. It was also contained in our whole numbers. It is also an integer, and it's rational. But then we also have these decimals that are weird, like pi, for the famous example, 3.14159, dot, dot, dot. There's no pattern to it. It does not end. We call those irrational numbers, non-repeating, non-terminating decimals. You do need to be careful though. Just because you see here the square root of 3, just because you see a square root does not mean it's irrational. The square root of 16 is 4. Therefore, we have to make sure that when we are determining what number set or sets a value belongs to, we need to make sure it's simplified first before we continue. To help out with our determining natural numbers, whole number, integer, rational, and irrational, there are symbols for each one of these sets we use. So let's make a note of these. Natural numbers use a capital N. Whole numbers use a capital W. Now you would say integers has to be a capital I then based off of what we see here, but that is wrong. Irrational numbers is the capital I. Integers is a capital Z. Rational numbers is not a capital R. Those are our real numbers. Rational numbers are Q. So we have our symbols. We use N, capital N for natural, capital W for whole, Z for integer, Q for rational, I for irrational, and we use capital R for real. Now to help you out with this idea of real numbers, a Venn diagram is very useful. If we take a look at this Venn diagram, we can see the whole idea is to think of it historically. Where did this number first originate? Did it originate in the natural number set, the whole number set, or the integer number set? And once you figure that out, you work your way outwards. So if I have a natural number, it's also contained in the whole number set and the integer set and the real rational number set. And so here, this picture comes from a site, mathandmultimedia.com. It's a very useful Venn diagram, and they have a very good explanation of the real number set. It says that the real number set is divided into two sets, a set of rational numbers and a set of irrational numbers. Now the rational numbers have several subsets. We see the natural numbers, we see the whole numbers, and we see the integers. They give us examples of those. And I say, needless to say, we can see from this figure that the set of natural numbers is a subset of the set of whole numbers, and that the set of whole numbers is a subset of the set of integers. And so we can see in words the explanation of what we see in the diagram. But if you're a visual person, maybe jotting this down or sketching this picture is very helpful to label what number sets values belong to.